Good evening, and how was your day been? Today we will be continuing on partial fraction. Partial fraction. Now, like I told you, that partial fraction is the opposite of polynomials. So today we want to deal more on partial fraction. Now, partial fraction, like I told you, takes the structure in which the denominator, the power of the denominator is greater than the power of the numerator. That if I have something like x plus 3 over x squared plus 5x plus 6, this can be resolved to a partial fraction. Why? Because the power of the expression at the denominator is greater than the power of the expression at the numerator. Now, partial fraction, we have 5 different types of partial fraction. 1, we have repeated factors. We have repeated factors. Repeated factors at the denominator. Yes, repeated factor at the denominator. When you have this kind of partial factor, it means that at the denominator, the factors there, they are repeated. Example, if I have x minus 7 over x plus 3, x plus 3. This is an example of repeated factor at the denominator. Number 2, we have non-repeated factors. Non-repeated factors at the denominator. Here, non-repeated factors at the denominator means that at the denominator, the factors are not repeated, they are distinct. Distinct means they are different. Example, if I have 2x minus 1, 2x minus 1 over x plus 3, 2x plus 1. You can see this one, the factors at the denominators, they are what? They are not repeated. That's number 2. Number 3, we have factorizable quadratic factors at the denominator. Factorizable quadratic factors at the denominator. In this note, it means that the quadratic that is at the denominator is factorizable. You can use factorization method to disable it. Example, if you have 5x minus 7 over x squared plus 5x plus 6, you can see this. I can factorize this one to give me something as 5x minus 7 over x plus 3, x plus 2. You can see that now. This is the factorized quantity of x squared plus 5x plus. If you expand, it will get this one. This is an example of factorizable quadratic factors at the denominator. Number 4, we have non-factorizable quadratic factors at the denominator. Non-factorizable quadratic factors at the denominator. This occurs when the denominators, the quadratic at the denominator, cannot be factorized. You cannot apply factorization method. Example, if I have 2x plus 3 over x squared, 2x squared minus 1x minus 12. If you apply factorization method under quadratic, you cannot factorize this. So this is an example of what? Non-factorizable quadratic factors at the denominator. The last one, improper fractions. Improper fractions. Now, what do we mean by improper fractions? In partial fraction, and when you come to improper fractions, these are quadratic at the denominator, and also these are partial fractions that do not obey the law of partial fractions. I think you keep my point. They don't obey. Remember I told you that the law of partial fraction is that the power at the denominator must be greater than the power at the numerator. But in these improper fractions, they don't obey the law of partial fractions. So look at it. You have something like x squared plus 5x plus 6 over x plus 3. You can see this. This does not obey the law of partial fractions. You can also have example as x cubed minus 3x squared plus 5x plus 9 over x squared plus 5x plus 7. They don't obey the law of partial fractions. This is number one, this is number two. In such situation, for you to dissolve the equation, you have to first use polynomials. When you dissolve the polynomial, then the remnant of it, you now apply your partial fractions method. And in partial fractions, there are two methods that can be applied. Methods applied in partial fractions. Method applied in partial fractions. One, you can apply cover up method. Cover up method. This cover up method leads us to simultaneous, the cover up method leads to you equating one of the factors to 0, get the value to use. That's cover up method. And number two, comparing the coefficient method. Comparing the coefficient method. This method leads to simultaneous equation. So, viewers, at this point, we have looked at the 5 types of partial fraction. The first one, repeated factors at the denominator. 2, non-repeated factors at the denominator. 3, factorizable quadratic factors at the denominator. 4, non-factorizable quadratic factors at the denominator. 5, improper fractions. Thank you. In our next class, we will now pick on this question and start applying it one by one. Have a blessed day. Thank you.